Hello, mathematicians! So we've been graphing parabolas, which as we saw before, was kind of a pain. You've got to make a table of values and so on. But how can I tell if a point is actually on that parabola, if it matches that rule? I have a point here. Does it obey this rule? Does it follow this rule or not? Now I could draw the parabola, but that would be a bit of a pain. So there is an easier way. And what we can do is we can recognize that if we have a point, then this is the x, so x is 3, and this one is the y, so y is 4. And if these two numbers make the equation true, bingo bongo, this point is on that graph. Okay, so we know for this point that x is 3. So let's imagine a world where x is 3 and see what y would be. Let's find out. So if x is 3, then we can write down this formula here, but in our little world, we're imagining that x is 3. So let's replace all of the x's with 3. We'll write the formula first, just as it is up here. But wherever we see an x, we're going to replace the x with the number 3. So this will be y equals. That minus I copy down, the equals I copy down, the squared I copy down, but the x we replace with 3. And again, the minus I copy down, the x I can replace with 3, and then I've just got this minus 1 at the end. Now, we can look at this one term at a time. This term here is negative 3 squared. I have to do this squaring first, so I get 3 squared. 3 squared is 9. So that would be negative 9. This minus 3, well, I can do this part here. Negative 3 take 1 is negative 4. So I've got minus 9 take 4, which is minus 13. Okay, so in a world where x is negative 3, y should be negative 13. But is that what we found for y? Is that what y said, what y was up here? No, it's different. There's a point 3, negative 13 that lies on the line, but negative 13 is very different to 4. So this point doesn't lie on that, I keep saying line, it doesn't lie on the graph. Okay, let's try another one. What about this point? X is negative 1, so if we think that if x is negative 1, that y should be negative 1 as well. Well, let's substitute. Let's imagine a world where x is negative 1. Let's just see what happens. Let's just play with it. So we'll write down the formula. So if x is negative 1, then, and we'll copy down this formula up here, but wherever we see x, we're going to replace it with negative 1. So the equals I can copy down, the minus I can copy down, I replace the x with negative 1, and I've still got the squared there. But there is a sneaky issue here, and you might be able to see the issue here with this negative number. The issue is that if I substitute a negative number in, I should really put it in brackets. If I don't put it in brackets, it's just the 1 that's being squared. But really, I want this whole negative 1 thing to be squared. The whole of x to be squared. So I'll put it in brackets to show that it's this whole negative 1 being squared. Alright, and then subtract, I've got a minus, and then I can replace x with negative 1. I don't really need brackets here. It's mainly when I've got squaring that it really comes in handy. So you can leave out the brackets here if you want, like I did. And then I've got minus 1. There is no reason that one minus is longer than the other. I just thought it looked nice that way. Okay, well, let's figure this out one term at a time. I can copy down my equals. Here I've got negative, but I need to figure out this thing. I've got negative 1 all squared. What is negative 1 times negative 1? It's positive 1. So this here I can replace with just 1. The negative I still copy down, but this part has been replaced with 1. Okay, now I've got a negative and a negative in a row. 2 negatives next to each other will make a positive. So that's add 1. And finally, I can copy down this subtract 1. Neato. All right. So y is negative 1, add 1, and then subtract 1. The answer to that is negative 1. Negative 1 plus 1 is 0. Then take 1 is negative 1. Is that what we expected y to be? Yes, it is. Cool. So does it lie in the graph? Yes, of course it does, because the y had the expected value. This point is on the graph. Now this all seems a bit silly, well, does it lie in the graph or not? But we can also use it to find things that we don't know. So if you have a formula that defines something, you know, like an arch bridge or something, then you can find, information about it. In this case, we've got a point where x is 2 and y is m, and we want to find m. Well, we can go through this formula. We can write down the formula and replace x with 2 and y with m. To make that a bit easier to see, you can put an x here and a y here when you have a coordinate. So now we know that x is 2 and y is m. So wherever I see a y, I'll replace it with m, and wherever I see an x, I'll replace it with 2. Okay, so I've got y, I'll replace that with m. Then I've got my equals. My x squared, but I'm replacing x, aren't I? I'm replacing x with 2. So I've got 2 squared, plus 3, and then I replace the x with 2. There is an invisible symbol here between the 3 and the 2. Between a number and a letter, the invisible symbol is a times. Okay, and then I've got this add 1 on the end. I don't need to do anything with that yet. All right, so therefore, m equals 2 squared is 4, 3 times 2 is 6, and then I add the 1 at the end. All right, we're getting warmer now. So therefore, m equals 4 plus 6 is 10, and add 1 to get 11. And that's how we find m. Cool. This last one is a particularly nasty one, so I'll record this one in a separate video. Bye everyone!